Okay, so welcome members. In this lesson today, let us see what we mean when we say a segment of a circle. And please don't forget to subscribe to the channel. Now, a segment of a circle, of course, we have seen what a chord is. Now, when a chord is drawn, it divides the circle into two things. What we call the minor segment and then the major segment, which is the big area. So, from here, you see that a segment is a part of the circle cut off by a chord. So, if this is my chord AB, you see that this one here is what we call the minor segment because it's the smaller segment compared to this, and this one is called the major segment. Now, this one here is what we call the center of that circle. Now, how do we get the area of a segment? Now, area of a segment, we know that if I want to get the area of this segment here, the shaded one, I know that from here up to here is a radius r, and from here up to here, because they are touching the circumference from the center, is also r. Now, if this one is having an angle theta here, theta degrees, it means that now I can get the area of this segment AB, the minor segment, or the shaded region, by getting the area of the sector A or A or B or AB, this sector here. We first get the area of this sector. Then, if we know the area of this triangle and the area of this sector, if we subtract the area of this sector and the area of this triangle, we can get the area of the remaining region. That's why you get the area of the sector minus the area of the triangle A or B. So, in simple terms, that's how we get the area of the minor segment. Then area of the major segment, of course, if we know this area, I know the area of the whole circle, we can get the area of the whole circle minus the area of this small segment. Okay, or the minor segment. So area of the circle minus area of the minor segment. Note, this triangle here, if I pull out this triangle and I put it here, theta r, the radius, so this is going to be by the isosceles triangle, and that's not the case I want to introduce. If you want the area of this circle, if you know the angle between the two sides, you have this side and this side, you can get the area as a half, the product of these two sides, then the angle between these two sides, sine of the angle between those two sides. So the angle is theta, so it's going to be area is a half times this area, this length times this, then sine of the angle between those two. But you see that our AO is R and OB is R also. R times R sine theta, which will be R squared sine theta. So, the area of this angle, this triangle race, is given by R squared sine theta. So, let's see some examples. Find the area of the minor and major segments of the circles below. I'm going to handle this, you will handle this in your free time. So now, I need the area of this segment. But to get the area of this segment, I need this minor segment, I need the area of the sector A or B, and then also the triangle A or B. So now, area of the sector A or B is going to be the same. Area of the sector is given by theta over 360, then times pi r squared. From the previous lesson, I think those who were around, you know how I'm coming about with this formula. So now, see from here, our theta is 150 degrees, and then our radius is 14 centimeters. So putting here, we have over, then times pi. Now here, let us take our pi to be 22 over 7. So there is 5b, then times the radius, which is 14, the whole square. And so now our area of that sector is going to be here I'm getting 256.6667. These are now centimeters squared. So that's the area of our sector. But we also need the area of this triangle. So now, area of triangle A or B is going to be, now we say it's going to be a half r squared sine theta from here. I think remember this formula here. So now I have the radius, I have theta also. So it's going to be now a half times, this is now 14 squared, then sine 150 degrees. And if you press that on the calculator, you have this is going to give me, this is giving me 784. Sorry, not 784, please. It's not 784. It's giving me 49 centimeters squared. Okay, all you are going to do, you are going to say this is going to be 14 squared. Then you divide it by, this is a half and this is a half, which is going to be you divide by 4. And that's the answer you get. So now, to get the area of the minor segment, we say it's going to be now this area here, the area of the sector, 7, then minus area of that triangle from 9. And what you get is here I'm getting 207.6667. Now these are going to be centimeters. I mean around the roof, these are going to be centimeters. Now square D. So now to get the area of the, now we are going to get the area around it, divide this to get the area of the major segment. I'm going to divide this here. Major segment now. Area of the major segment. Here we are going to say, we say we need the area of the circle then minus area of the minor segment. So we first get now the area of the circle. So our area of the circle, we say it's pi r squared. This will be r pi, then times r radius from here is 14, the whole square, which will be now here I'm getting 616 centimeters squared. So now area major segment will be now this area minus the area of the minor segment. So we shall get 616, then minus the area of around 20 here, minus the area of this minor segment, which is 207.667. And see my area is going to be is going to be 408.33 centimeters squared. So that's how we get that numbers. So how do we get it? I repeat, we get the area of the small sector, we get the area of the, the area of the segment, minor segment, we get the area of the sector, minus the area of this triangle. This is how we get the area of the triangle, area of the sector, then area of the triangle, then we get this, minus this, we get the area of the minor, then area of the major, we get, first of all, area of the circle minus area of the minor. So area of the circle is here, then area of the minor is here, when subtract the two, that's what we get. I wish you the best.